Okay, this is the limit law, like the one that you're going to use most of all. So you might want to write this down at the bottom of your sheet there. That'll be fine. If you have a polynomial or rational function and a is in the domain of the function, that's the requirement. Okay, so a lot of times you get a rule, it says if some stuff happens, then you can use this rule. The requirement here is we have a polynomial or rational function and the value of a is in the domain. In other words, if you put a in, it does not create an undefined. It doesn't create division by 0. It doesn't create a square root of a negative number. All right, so you're creating a number that's possible. Okay, then this is a valid truth. Limit of the function as x approaches a is just f of that number. For example, x squared minus 1 is a polynomial function. The domain of x squared minus 1 is all real numbers. Okay, there's no number in the world that I can't put into there to square and then subtract 1 from. Okay, squaring anything is possible, subtracting 1 from anything is possible. So all numbers in the world would work on that function. So as far as this, it is a polynomial function, and a, which is 2, is in the domain of this function. Okay, the answer to this problem is simply going to be 2 squared minus 1. Just replace all the x's with that number and work it out. All right. For me, doing a limit, that's my first step of every single limit. Stick the number and see if I can work it out. If I can, I'm allowed to. Okay, if I can't, then I got to do something else. All right, but anytime I see LIM of anything, I just put the number in. If it works, I'm ready to go. If it doesn't work, I got to do something. Okay, and we're going to see that in examples 2, 3, and 4, where we try and put the number in, weird things happen, we try and fix it, and then we can do it. All right, so if you can get a limit down to this level, you're allowed to just put the number in. All right? Looking at example 2. Evaluate the limit if it exists. I don't know why I got this graph here, but I do. You don't need a graph for this. Maybe I graphed it after I was done one year in the state. All right, let me get some white paper here to write on. All right, so first step, I see LIM, and I'm not in that section where it says justify all your steps. My first step is simply going to be put this number in that expression, see what happens. All right, let's try it out. So if I put 1 in, I'm going to get 1 squared minus 1 over 1 minus 1, which makes 0 over 0. Okay. Let's go back in time to Algebra 1. And I can't remember what lesson it was, maybe lesson 10 or 11 or 12, somewhere in there. And we dealt with division by 0. Okay? And if we had 0 divided by a number, we had 0. If we had a number divided by 0, we got undefined. But if we had 0 divided by 0, we had indeterminate. You might recall that word. And my insistence that the word indeterminate was much more important than undefined, because when you get to calculus, it actually means something. Okay, that's 3 years ago, around this time of year, because we're like lesson 9 today in Algebra 1, so it's probably around the same time of year. I was being nitpicky about the word indeterminate versus undefined. Some of you were just stubborn. I'm going to write undefined every time I see 0 on the bottom. But I really got out of you. You have to write indeterminate. Indeterminate means it might equal something, but we don't know what it equals. Undefined means it doesn't equal anything. It goes to infinity or negative infinity. But this could possibly equal something. So, again, first step, put your number in, see what you get. If you get 0 over 0, it's indeterminate. What that means is it might have an answer, and we might be able to figure out what that answer is. Okay, let me rewind 2 days. All right, actually 4 days. Friday. All right, we were evaluating limits using numerical techniques, right? All right, if you can't figure out how to make this work any other way, numerical techniques work. You make a chart, you pick 0.9, 0.99, 0.999, and so on. You pick 1, 1 point, or 1.1, 1.01, 1.01. Get really close from both sides to see what it's approaching. All right? If you can't make it work any other way. But there is algebra you can do to make this work, and it happens quite often. When you get 0 divided by 0, quite often factoring and canceling allows you to simplify the expression to where you get to a point where you can substitute the number in. So watch what happens here. If we look at the top of this expression, x squared minus 1, how does that factor? X plus 1 times x minus 1. It's just a difference of squares. Every level of factoring you've ever learned is alive and well in this section. So taking out a greatest common factor, difference of squares, quadratic trinomial with guess and check, factor by grouping, perfect square trinomial, sums and differences of cubes. Any type of factoring you've ever learned is alive and well in this section. If it comes to quiz time, you're looking at something, you know factors, you can't remember how to factor it, use a chart, get an approximate answer. If your approximate answer is exactly 100% right, you're in good shape. If it's slightly off, I'll probably deduct a point or two for not doing it the algebraic way. Because there are ways to get the exact answer. If you can get the exact answer with the chart, great. If the answer is 6 and you get 6, you're fine. If the answer is 1/17 and you give me like whatever 1/17 is, 1.053 or something like that, I'll probably deduct a point for not having done it the algebraic way. All right. Anyway. X squared minus 1 is just x plus 1 over x times x minus 1. And on the bottom of this expression is x minus 1, which doesn't factor. But what you'll notice is x minus 1 on top, x minus 1 on bottom are common factors that cancel. So x plus 1 is equivalent to x squared minus 1 over x minus 1, except at the value of 1. At 1, this has a hole. At 1, this doesn't have a hole. All right? So if we take a look, limit as x approaches 1 of x plus 1, what does that equal? 2. We're at the point now, once again, where I started off. I put the 1 in, I worked it out, got 0 over 0. Now I put the 1 in, 1 plus 1 equals 2, and that's my answer. Now, for the sake of me having graph paper up here, let me just take a look. I'll do the next two problems quickly because I'm running out of time. Here we go. If I graph the first one, parentheses x squared minus 1 divided by parentheses x minus 1, I'm just going to go from 0 to 4. And let's go from -1 to 5. Oops. All right. If you check this graph out, at 1, you see there's a hole there. There's a gap. It had to skip 1. It's a straight line, except for that gap. Notice x plus 1 makes a straight line, right? Suppose I graph x plus 1 on top of that. Makes the same line, now the gap is filled in. That's all you're doing. It's called a removable discontinuity. Okay, there's a gap, a hole, but it can be removed algebraically, which allows us then to figure out what the exact answer should have been, not using any kind of tables. Algebraic techniques to solve a limit. All right. The trick, though, is that how do you simplify that expression? Is it factoring? Is it simplification? I don't know. It depends on the structure. So we're going to look at several different structures. This is one, factoring. The next two have to do with simplifying and some weird stuff with radicals.